In this demo, I want to show you the effects of air pressure and just how strong air pressure is. Plus, I want to show you the difference in the volume of a gas and a liquid. So first of all, the air pressure is all the air above your head pushing down on you. It's like you're underneath this big ocean of air and all the air is pressing down. You're like, wait a minute, I don't feel this air pressure. What are you talking about? What? Don't you feel the weight of the world on your shoulders? Okay, maybe not. So what's the deal? The reason you don't feel the air pressure pressing on you is because you have the same amount of air pressure inside of you pushing back out. And this is why your ears pop when you go up in an airplane, in an elevator, up a mountain, because the air pressure is changing. There's less air above your head, therefore there's less air pressure, and so therefore your ears pop to equalize the pressure inside of you and outside of you. So let's take a look at just how strong air pressure can be. What I'm going to do is to light this portable Bunsen burner, and I'm going to get just a little bit of water in a can, not much, just enough you can hear it sloshing around. And we're going to heat this water until it boils. And you'll want to heat it until it is so hot that the steam is just pouring out the mouth of the can. So a good rolling boil. Okay, we have lots of steam coming out of the can now, so the water is boiling very well. And now we're ready to see the effects of air pressure, just how strong air pressure is. I'm going to dump this can upside down in that water, and the air pressure is going to, well, do something surprising. Wow! That crushed up fast and tiny, didn't it? That's how strong air pressure is. Air pressure was what made that can crush. So, what about the difference between the volume of a liquid and the volume of a gas? Well, when we boiled the water, the steam was filling up the aluminum can. And the steam, of course, is a gas. Then, when we put it in that cool water, then the steam condenses, turns back into a liquid, and only takes up as much space as a liquid. Therefore, the pressure inside the can decreased greatly because there wasn't the gas pressing on the sides of the can anymore. In fact, that's what causes gas pressure. The pressure of the gas bouncing around inside the can and hitting the walls of the container causes the air pressure. And so when the pressure was decreased because the gas took up this much space and the liquid only took up this much space, then the air pressure outside was much stronger than the air pressure inside, and it crushed the can. So let's see that one more time. So now that it's starting to boil and there's steam coming out of the can, the water vapor has expanded and is filling up the can and has driven a lot of the air out. So now it's just the water vapor, and when we cool down that water vapor, it will turn into a liquid, and then the liquid doesn't take up nearly as much volume as the gas does, and then the can will be able to be crushed. Wow! So there we are again. Definitely much lower air pressure inside the can than